again, what looked like I was in focus at low magnification, at high magnification, wasn't in good focus at all. All I do is click in the model window any place, and it creates the measurement step for me. I can come over to another point, and this part's certainly going up in height as we go across it. Another point here. And we'll go back to the beginning and take another point. Now what I would do is tell it if I wanted the distance between these points, I would tell it to give me the distance, and I'll show you how we do that in just a moment. Select the third point. Say OK. Alright, if I want the distance between the first point and the third point in Z, I just say construct distance, which is the fourth icon, and I pick the two features, one and the third one, and it told me that the Z distance was 1.64 millimeters between the two. Right, to go down and measure with the laser now, I'm going to go back to low mag so we can see the part. Alright, I'm going to select the laser target, and right now we're set on a laser scan. I can do an arc scan, a circular scan, or a box scan. Where you might use a circular scan would be if I was measuring the top of a bottle. And the top of a bottle is a sealing surface. So the flatness is critical. If the top isn't flat, then when I screw the cap on, it's going to leak. So we can just tell it 3 points around the top of the bottle. It'll do a circular scan with the laser where we can have thousands of points very quickly and physically measure the flatness without any issue. An arc scan is just a partial circle. A box scan would be if I wanted flatness of something. Right, I can describe the limits that I want it to scan in and how many rows I want, and it'll go evaluate the surface. And by saying I want to measure a plane, I'll have this flatness. I can also do a focus point with it. So I'm going to tell it we want a linear scan. Right now we're set to take a point every, I'm going to tell it every 20 microns. Right, I'm going to go to advanced for just a moment. Right, in advanced we have the power level, the speed. I'm going to turn the speed up just a little bit. I have focus first. What that does is it's going to, before we start measuring, we're going to focus on the part with the laser to be sure we're in the center of the capture range, which will enable the laser an easier time of finding the surface. So I just click one point for my start point. I go over to the other side of the part. I'm going to bring it back into focus, medium, and I click another point. Now I just say scan. Alright, now, while the laser's scanning, certainly you don't see anything in the video window. The first beep you heard was the focus. It's going along the part now. Now, we're looking at the model right now in the XY plane. So for me to look at this scan, I need to look at it in the front view or the XZ plane of the part. And it's done now. Alright, when I say OK, we measured 2,362 points in that scan. When I say OK, you'll notice that we have a line through the focus points. If I go to View, Model, and Front, now you see the contour of the shape that we measured with the focus points along them. Now, we had approximately 2,300 points, a little bit more than that. If I wanted to measure and see what these radiuses were, I can come up and say construct a circle now. And from those points, I can just tell it where to start. Tell it to take a point here and stop here. And across that, I've got to be in the correct plane, which is the XZ, of course. It said that the size was 8.562 millimeters. All right, that's the radius across that section. If I wanted to measure another radius in here, I can come back and say again. All right, again, I want it in the XZ plane. And I just tell it where my start point is and where the end is. And evidently, tell it once more. Now I'm start here and end here. Okay? The first time I took much too large a section. This is more realistic. And now it's telling me the radius is 4.929 millimeters, which is very close to the nominal size. Let's go back and run everything once again. The first thing it's going to do is put the laser away, park it. because it knows we didn't use the laser or wasn't deployed during the measurements that we started with. So the system automatically puts the sensors away if they're not the sensors that are called for in your measurement, and then it recalls them when you need them. Now again, the system mimics everything that I did. We measured the holes, we're measuring the slots, we'll measure the corner. We went over and used the manual point entry to measure the circle. And again, with the manual point entry, I've got to physically go back and select the points. After we're done with that, we used the feature finder to measure the circle. We deployed the laser, and after we deployed the laser, we came down and scanned the part. Again, the laser has the ability to measure points for z-axis focus. You can measure a plane using lines to create the plane. We can do a circular scan if we want to measure the top of a bottle. I'm focusing with the laser right now. And again, the laser focus is much faster and certainly more accurate than the video focus. Now we're actually scanning the part. And again, while the scan is taking place, the speed of the scan is determined by the exposure, how much power we're telling the laser to use, and how fast we tell it to physically run. It's governed by point spacing and then the rate of change. If I want to get a very accurate representation of your part, I can't zoom along at lightning speed. I have to go at some reasonable amount. The last sensor we have to show you is the touch probe. And for me to show you the touch probe, what I'm going to do is just select the probe. It'll automatically, I'm sorry, before I do that, I want to retract the laser before I select the probe. And to retract the laser, I'm going to go up to Targets, Tools, Change Sensor, Retract Laser. And we want to put the laser away so that it's not going to interfere. The laser sits down below the light, below the big ring light while it's measuring. I want to get it out of the field of view so that I don't take a chance on, encountering any of the other parts as we're going through. Now I'm going to go tell it to pick up the probe. And again, we're using a probe, a disengageable stylus module that's in position 2 on the Renishaw probe rack. So I just say OK, and it goes over and picks that up for me. All right, now when we measure with the probe, all it does is copy whatever I did, however I moved. I'm going to come back and let's measure the diameter here first, the outside diameter of this part. To measure the diameter of the part, I bring the probe up near the surface. I'm going to say measure a circle. Now again, when we're measuring a circle, the system doesn't care whether it's an ID or OD, because it knows when I come in for a touch it has to back off, so it automatically determines that by itself. So I just come in and I touch. Once I touch, the system automatically backs off. I'm moving the machine and then I'm recording the position I move it to as the vector direction for the machine to drive in as it measures. So I just measured 3 points on the part. And my 3 points weren't equally spaced. There's nothing about them that's normal, if that's a good word for it. There's nothing wrong with the points. They'll physically work. And I can come back now and save my program. If I rotate the model up, let's just go to top-down surface. We'll see, and again, I measured a radius on the part. I'm going to go back and change that to a diameter, set for diameter. Okay, so now we have a diameter rather than a radius. If I want to measure more parts or equally space them, I can come back and select that feature. And rather than take auto points where we were set when we started, I can be an auto path. And as I do this with a plane and a line, I'll show you the same thing, just so you can see the difference. I'm going to go to Advanced now. And when I go to Advanced, rather than taking those 3 points that I put in randomly, I'm going to tell it to take 6 equally spaced points. And then I've told it that I have a safe distance. When I'm done, I want it to go up above the part. Now, right now, I'm clear of the part, and I'm sitting about 72 millimeters, so I'm going to have it go up to 76. When I say Apply and say OK, I can go back and say Remeasure now. And now, instead of taking the 3 points we took at the random locations,